Hello everyone, in today's video I'm going to talk about AC and DC voltage and how do we represent them mathematically. As you know, voltage generator could generate a combination of AC and DC voltage, this one being the DC and this one being the AC, and they are separated with the plus sign. And we picked up a random frequency in here which is 500 Hertz. So first of all, we should know what does the omega represent in here. Omega in here is actually 2 pi f, or frequency. So why do we use 2 pi in here? So 2 pi in here actually represent a full rotation, and then in a circle or a full rotation. So if you would have a circle like this, it being 0 to pi over 2 pi and 3 pi over 2. So actually when we start from 0 and we would go like this way back to where we are, we know that it's 2 pi in here. So for us, a full rotation, it means 2 pi. From 0 to 2 pi, it means a full rotation. So you might ask yourself, what does the full rotation have to do with the AC voltage? As you know, the AC voltage actually is fluctuating. So if you would look at the graph of an AC voltage, first of all, at first it doesn't make sense, but this one being the graph and this one being the circle. So we had 0, pi over 2, and pi and 3 pi over 2. So when it reaches in here, actually it depends if the signal that we have, is it a sine or a cosine wave. And the difference is that sine of 0 is 0 and cosine of 0 is 1. So at 0, if we have a cosine, it's 1, and at 0, if it's a sine, it's a 0. So for example, we would pick up a sine. So we assign 0 in here, but this one, it's a temporal graph, so it depends on the time. So as we go in the time, this being 0 seconds until the t seconds. So as we go, for example, this one would go this way, okay? This one goes this way, this one goes this way, and it would create something like this until when it reaches in here. And as we go down in here, this one goes in here. So if you would represent, if every point in here, this one would go this way until it's in the pi. So in here it's 0, pi over 2, and pi, okay? And it goes minus in here, so we would also go minus until this one being pi, 3 pi over 2, or 70 degrees, okay? And it goes back until in 0, or also we could represent it as 2 pi. So it's something like that. So if for example I pick up my my glass, this one being the 0, and the signal would be created this way. So when I look at it this way, it doesn't really make sense a lot, okay? But if I would look at in this way, this being a point, it actually fluctuates. It goes up and down. It being here, it goes up and down. So if I would represent this circle in the other way, it would be a straight line, okay? And in this straight line, as it's moving, it's going up and down, up and down. So it creates the frequency and the fluctuation. That's why we use the cosine in here. And yeah, 2 pi is the full period or full rotation, which means that it goes up, comes down to the negative point and or the extreme, and it comes back to the zero. So that's why we use the cosine and or sine or and also omega. But what does the F and T means here? You already know that F means the frequency. In here it being 500. So it does also mean 1 hour period. Okay, so the period is 1 hour 500, or it being 0 0.0 0.002, I think, something like that. So it's we will take it as if it would be 0.002, so seconds. So it takes like 2 milliseconds for one rotation, or starting from 0 to 2 pi. So this way we know that when we put the frequency in here, so the graph is the DC part in here, we have the AC part, we had the 3 cosine of 2 pi f t. Okay, instead of f we would put, if we would put like 500 and of that t. Let's not consider the t for a moment right now. Like, it means that we are doing 500 rotation or 500 complete circles, or if you would look at it this way, 500 times going up, down, and back, coming back to the starting positions. 500 times in a second, 500 hertz. But why do we have t in here? It represents the time. For example, if we put the t as like 2 seconds, what does it mean? Actually, it means 500 times 2, so it does like 1000 rotations in 2 seconds. So this signal does 100 rotation in 2 seconds with, in here I didn't mention this one in the equation. Actually, this 3 or whatever number that we have shows the amplitude. Okay, so this cosine wave does like 1000 rotations in 2 seconds with the amplitude of 3 volts. But you should remember, it's the 3 in here, it's not 3 VPP, as VPP represent the peak to peak, one peak being in here and the other in here. So the peak to peak is the combination of these two, and it being 6 volts. Okay, so the other thing, what does the DC represent in here? When you look at the oscilloscope, the DC actually represent the offset, or the difference from the zero voltage. For example, we have an offset of 1 or +1, since it doesn't have a sign, it's a plus. So we have a +1. We have this voltage in here, so it should represent. In here we would do, if it would be 1 volt in here, -1 volt. So the DC component in here is 1 volt. So we would go 1 volt up, and after that we would draw the AC part being 3 cosine of omega t, or 500 hertz. So in here we start and we draw this one like this. So now the maximum amplitude of the AC voltage is not 3 volts, because we have an offset of 1 volt. So it becomes 4 volts, okay? And this part, it becomes less, so it becomes 2 minus 2 volts. My graph is a little bit off, so bear with me. So yeah, that's the logic behind the equation that we use for the AC and DC component. But the important thing, why do we use cosine? Actually, what's cosine? Cosine and sine, we pick them up from the unit circle, okay? From the unit circle. Why do we pick up the cosine and sine? Because sine and cosines goes negative and positive, and fluctuate between the negative and positive, and that's exactly what we do when we represent an AC voltage, because it goes to the minus or negative part and to the plus. So we use that because of this. So I hope you learned something new. Thank you.